So this is the next topic in Unit 13. We're going to be evaluating inverse trig expressions using what we discussed in the previous video. So what I want to look at first is what will these expressions look like. For non-inverse trig expressions, I don't like how this is set up. I need to change this. And it's because on the unit circle, we have the coordinates x and y. So using x and y as inputs and outputs for these trig expressions can get confusing because, yes, we use x as inputs, but for cosine, the input is theta, and on the unit circle, the output is x. Now, we also learned that it could be x over r, but for simplicity's sake, we will just say x is equal to cosine theta. And then we can also say that y is equal to sine theta. And we can include tangent as well. Y over x is equal to tangent theta. And I'm using these three because these are the three that we talked about in the previous video. So for non-inverse trig expressions, the input will be an angle from the unit circle, aka in this case, theta. And then the outputs will be the coordinates from the unit circle. So for tangent, that's y over x. For sine, that's y, and then for cosine, that will be x. So if we switch these, if we go to inverse land, where the inputs and outputs were switched, I can now, or another way to think about this is if we start with cosine, I'm taking the arc cosine of both sides. So arc cosine of x is equal to arc cosine of cosine theta. And when we do this, think about the square root of x squared. The square root and squared are both inverses of one another. Therefore, they cancel each other out, so we're left with x. Inverse trig is no different. It's still an inverse. So that means arc cosine and cosine will cancel one another out. So we're left with arc cosine x is equal to theta. So now we can see that the input is going to be the x-coordinate from the unit circle, and the output will be theta. And this is how all inverse trig expressions work. So if we look at sine, if we take the arc sine of the coordinate y on the unit circle, the output will be that corresponding angle. And then if we take the arc tangent of y over x, of that, the ratio of that coordinate, the output will be the corresponding theta. So that's what we're going to be looking at in this one is how do we evaluate these, but you have to switch how you normally look at trig expressions. So just a quick recap, thinking about arc cosine. So we had a couple changes to our domain and range. For arc cosine, the domain is going to be -1 to 1. And that's because for cosine, the range is from -1 to 1. So we use that in order to establish the domain for inverse cosine or arc cosine. And then the range for arc cosine, we are restricted to quadrants 1 and 2. So that means the outputs, our angles, are going to be from 0 to pi. For inverse sine or arc sine, if you think of sine x, the range for sine is going to be -1 to +1, which means the domain for arc cosine is going to be -1 to 1. Now for arc sine, you just have to think about being restricted to quadrants 1 and 4, and it has to be connected. So it's going to be from -pi/2 to +pi/2. And then for inverse tangent, if you think about the non-inverse tangent expression, the range is going to be all real numbers, which means that will be the domain for arc tangent. So we'll have all real numbers for the input, and then just like arc sine, tangent's range is restricted to -pi/2 to pi/2, but remember it's in between two horizontal asymptotes, therefore it will never be equal to those values, so it's non-inclusive. So this is important as we go forward. You have a calculator for this unit, so you can always double check, but it does waste time if you're not familiar with the coordinates on the unit circle, okay? So this says evaluate each trig expression. So this is a review. Some of these are just non-inverse trig expressions where we can just, it's like practice from previous couple units. So sine of pi over 6, no domain restriction, it's just sine. Pi over 6 is in quadrant 1, and it's going to be closer to the x-axis. Therefore, that y-coordinate will be 1/2. Number 2, cosine of negative pi over 3. We're using a coterminal angle going in the negative direction. It's family of 3, so it's closer to the y-axis. Therefore, it's going to have an x value of 1/2. So this is the x-coordinate. Actually, let me just write x. We don't have to write coordinates. So that's x. And then this first one was the y-coordinate. Number 3, we have tangent of 5 pi over 4. So 5 pi over 4, we have pi over 4 here. We have 3 pi over 4, and then 5 pi over 4 is in quadrant 3. So in quadrant 3, tangent is going to be positive. All students take, we'll say calculus because it's a math class. All students take calculus, okay? So tangent is positive in quadrant 1 and 3. And that's because both coordinates are negative. So at this coordinate, we have negative 1 over root 2, negative 1 over root 2. They are the same. Therefore, the ratio of those two values will be 1. Also, it's family of 4. Hopefully you know by now that tangent for all family of 4s will either be 1 or negative 1, depending on the quadrant. Number 4 is sine of 5 pi over 3. So here we have pi over 3 in quadrant 1, 2 pi over 3 in quadrant 2, 4 pi over 3 in quadrant 3, 5 pi over 3 in quadrant 4. And because this is sine, we're going to use y. We are closer to the y-axis, so it's going to be negative root 3 over 2. Okay, number 5, we have cosine of 7 pi over 6. So review for family of 6s. We have pi over 6 in quadrant 1, 5 pi over 6 in quadrant 2, and then we have 7 pi over 6 in quadrant 3. So remember, all of these angles are standard position, so we're opening from the positive x-axis, or a positive input axis. So for this one, we are closer to the x-axis, and we are going to the left, so we have negative root 3 over 2. Number 6, we have sine of negative pi over 4. Negative pi over 4, we're going to travel clockwise, and we're going to split the fourth quadrant. So family of 4s, this is root 2 over 2, or 1 over root 2. The y-coordinate is going to be negative, so that means we will have negative 1 over root 2. Now we are shifting to the focus of this topic. Okay, now that we kind of reviewed the unit circle and how we evaluate using non-inverse trig. So my suggestion is that whenever you see whatever inverse trig you are evaluating, immediately restrict yourself to its outputs. So arc cosine only exists in quadrants 1 and 2, from 0 to pi. Okay, so with these other problems, I was working from the inside. I had my theta. So I was working from the center and I opened up to wherever that angle was, and then I traveled out in order to find out what that coordinate was, or what those coordinates were. For inverse trig, it's the opposite, okay? So I know I'm restricted to quadrants 1 and 2 for arc cosine, and I also know that cosine is x. So I need to find the x value within this restricted domain that is root 3 over 2, okay? So this input, that is x. That's the x coordinate on the unit circle. And it's positive root 3 over 2. X is positive in quadrants 1 and 4, and it's negative in 2 and 3. But we only have one option, okay? We can only be positive in quadrant 1 because arc cosine is restricted to quadrants 1 and 2. So if I think about root 3 over 2, I'm traveling further away from the y-axis, okay? So I found where my coordinate is x equals root 3 over 2. Now what is the corresponding theta? That's going to be pi over 6. All right, so now we have inverse sine of negative root 3 over 2. So now we have to switch the details, okay? Inverse sine exists in quadrants 1 and 4. 1 and 4. And now we're not looking at the x-coordinate. This input is a negative y-coordinate because sine is y. That relationship will not change, ever. So if I want the coordinate where the y value is negative root 3 over 2, sine is negative in quadrants 3 and 4 because we go down for negative y values. However, it does not exist in quadrant 3, so it has to be in quadrant 4. So if I travel down, I'm going to be closer to the y-axis because this little triangle in here, I have 1/2 and then negative root 3 over 2. And then the question is, what is that corresponding angle? Most people will say, oh, that's 5 pi over 3 because we're used to looking at our unit circle going this way. But if I travel counterclockwise, I can't go past pi over 2. The angle has to be connected. So that means I have to try the other direction, and we are able to get there. So you have to use a coterminal angle, which means we will use negative pi over 3. So the answer is negative pi over 3. 5 pi over 3 would be incorrect, and if you plug this into your calculator as inverse sine of negative root 3 over 2, it will give you a negative decimal value. You will not get the positive 5 pi over 3 decimal value. All right, number 9, we have arc cosine of 0. Okay, so now we're back to arc cosine. This only exists in quadrants 1 and 2. A common misunderstanding is that, oh, 0 is going to be over here, all right? This is an inverse trig expression, which means the input is not an angle. It's not theta. Because it's arc cosine, it's actually going to be an x-coordinate on the unit circle. So this is an x-coordinate on the unit circle. So if we think about that, yes, this is 0 for theta, but 0 on the unit circle for the x-coordinate is going to be here, which means this is going to be our corresponding angle. Therefore, theta is equal to pi over 2. And that's what arc cosine of 1 is equal to. Now we have arc cosine of negative root 2 over 2. Again, arc cosine is restricted to quadrants 1 and 2. We have a negative x value. Okay, so this is a negative x coordinate on the unit circle, which means we will be in quadrant 2 because cosine is negative in quadrant 2 and then positive in quadrant 1. So this is going to be the family of 4s. Hopefully you recognize that, which means our theta is equal to 3 pi over 4. Arctangent of negative root 3, this is going to be in quadrant 1 or 4 because arctan is only in quadrants 1 and 4. All right, so tangent is going to be positive in quadrant 1 and then negative in quadrant 4. So this tangent is going to be the ratio of y divided by x, okay? So this can be a little deceiving because, wait, I only see one value in there. If you only see one value, think about the number 3. Technically, that's also equal to 3 over 1. Or if you think of x, that's equal to x over 1. So in this case, that negative root 3 can be rewritten as negative root 3 over 1. And that's our coordinate. That's our y over x. The only thing that's missing is that within our quadrants, they all have a denominator of 2, so they cancel out. So if I think about that, I have root 3 over 2 divided by 1/2. And now I can see the coordinate point, okay? Now, which one is negative? Based on our possibilities, we can't have a negative x value because arctangent does not exist in the negative x values, which is quadrants 2 and 3. So that means your y value is negative, which would be the root 3 over 2. Okay, and that gives you your coordinate point. The coordinate is 1/2 negative root 3 over 2. So that is our x comma y. Another shortcut that you can remember is that if you see a big 3, that is going to be a family of 3. All right, so that's going to be either pi over 3, 2 pi over 3, 4 pi over 3, or 5 pi over 3. So if you see a big 3 in there, a big 3 with a root, it's going to be a family of 3. But 3 of these don't exist. All right, we only have 2 options for family of 3. It's either pi over 3 or negative pi over 3. And in this case, since we are in the 4th quadrant, that means this one will be equal to negative pi over 3. So there's a lot of ways to figure out what this is. My suggestion is pick one way and then just stay consistent with it. I think this way is more beneficial because once we get into arc cotangent, you just flip this method and then it's easier to remember how to find out what that coordinate is. All right, the last one, arc tangent of -1. Again, we're going to be in quadrants 1 and 4. And then -1, that's a ratio of y over x on the unit circle. You have one option, that's your root 2's, okay? And because it's negative, that means one coordinate is positive, one is negative. So we have to be in quadrant 4 because tangent is positive in quadrant 1. So this will not be 7 pi over 4. This is going to be negative pi over 4. All right. Question, will arcsine x ever equal 3 pi over 4? Well, arcsine exists in quadrants 1 and 4. So that means we have positive pi over 2 to negative pi over 2. 3 pi over 4 is in quadrant 2, which arcsine does not exist in, so the answer is no. Because 3 pi over 4 is out of range for arcsine, because the range is only from negative pi over 2 to pi over 2. Will arc cosine ever equal 3 pi over 4? So this is the same question, but now we're using arc cosine. And because arc cosine does exist in quadrant 2, the answer is yes. Because 3 pi over 4 is within range, or I should say within the range of arc cosine. And then we also have a couple problems here at the bottom. So throughout this unit, not all of your evaluations will have a coordinate that is standard on the unit circle like all of these did. They could be something that's not on there, but that doesn't mean we cannot evaluate it, okay? So we have arc cosine of root 3. So that root 3 is deceiving. This root 3 is special to tangent and arc tangent only. Not for cosine, not for sine, okay? The only time that we should see a root 3 is if there's a 2 under it for sine and cosine, okay? If it's just root 3, that's tangent and arc tangent specific, which means we cannot evaluate this using a standard coordinate on the unit circle. Now, arc cosine exists in quadrants 1 and 2. Again, always draw a sketch just to make sure that you know what you're looking for. And because this is arc cosine, that is an x value. So you might think, okay, we need to go to the calculator. Yes, if because this is not a standard angle, you do, but there's an issue with this one. The domain for arc cosine is going to be the range of cosine, which is from -1 to 1. Root 3 is about 1.7. So if you type this in the calculator, you should get error, which is good. That's a fail-safe for you, okay? So therefore, this one is undefined because it is out of the domain for arc cosine. So the calculator will save you, but you don't have enough time to type every single one in the calculator. All right, let's try arc tangent of -root 2. So negative root 2 is not a ratio of y over x that is standard on the unit circle. All right, and then we need to think about arctangent exists in quadrants 1 and 4. But this isn't like the last one because the domain for arctangent is all real numbers. So no matter what input you get, all of those inputs will fit within the range, which is negative pi over 2 to pi over 2. So now I'm going to switch to the calculator. Okay. So your arc, or your inverse tangent, cosine, and sine, it's going to be with the sine, cosine, and tangent. You just have to hit second first. And they have the -1 instead of the arc on there, probably because it fits better with the keys. Okay, so we had arc tangent, so second tangent, of negative root 2. So negative square root of 2. Close it off. We get a decimal approximation of negative 0.955. And of course, you always want to do 3 decimal places. So this is negative 0.955. So even though this is a decimal, it is still radians. It's just in decimal form, okay? So all of your unit circle, it can also be written as decimals. So this is 0. Pi over 2 is about 1.57. Pi is 3.14. 3 pi over 2, I can't remember what that was. I should be able to do the math. 3.14 plus 1.57, we get 4 that becomes an 8 raised to 2. I think it's 4.28 or 4.38. Well, embarrassing that I can't do mental math. So 1 to 7. Math is not mathing. Let me double check. If I could edit this out, I would, but I don't have time for that. So 3 pi divided by 2, 4.71. Oh, okay, I was right. Where'd I get 4.28 from? That's from something. I can't remember, though. So it is 4.71. Oh, I was mixing the two because 360 is 6.28. Okay, so that's what was happening. So we got negative 0.955. Now, if we think about our inverse tangent, we don't have that 6.8 or that 4.27 or that pi over here. We have 1.57 and negative 1.57 because we only exist in quadrants 1 and 4. So that means this angle is about right here, okay? Pretty close to the y-axis. So don't let that trick you. Yes, it's a decimal, but it is still in radians because if you look at your calculator, it is in radian mode. So your outputs for your inverse trig functions will be in radians. All right, arc sine of 1/4. This is not a standard coordinate. Keep doing purple. This is not a y coordinate on the unit circle, so not a y coordinate. Now the next thing is we have to check, is it within the domain? So the domain for arc sine is going to be -1 to 1, and it is. We have 0.25. And then arc sine exists in quadrants 1 and 4. Okay, so we will type this in the calculator. Let's see. All right, second mode. So now I'm going to do second sine, and then it's 1/4, but I'm going to type 0.25. And we get 0.252. So this is equal to 0.252. You can also round up and do 253 if you want. Also for this one, I did an approximation. This one, I did not. You will not get docked for that, okay? Just choose whichever one you're more comfortable with. Obviously, this one is more accurate because it's not exact, but they're not going to dock you for that, and neither will I. So that means this one is in quadrant 1, so it's about right there because this is positive angles and negative angles. The last one is arc sine of 9/14. All right, now we could get an exact value. We'll talk about that later, but this is a coordinate, but it's also, if you think of SOHCAHTOA, you have your opposite side and your hypotenuse of a triangle. Now, you would have to use Pythagorean theorem to get another part, but there's multiple things that we can do with this, but for now, just ignore that. So we are in quadrants 1 and 4 for arc sine. And the domain for arcsine is -1 to 1. So is this within the domain? Yes, because it is less than 1 and greater than 0. So we are going to end up with an angle that is in quadrant 1. So if we type this in the calculator, we will have second sine, 9 divided by 14, and we get 0.698. So this is about 0.698. So that'll also be in the first quadrant somewhere. All right, that's it. And then I will talk about inverse reciprocal trig expressions in the next video. Hope this helps.